Okay, so here's a video that's going to show you how we are asking students to multiply fractions by whole numbers. So we've given them different strategies, quite a few different strategies actually, and the way they break down fraction multiplication, it makes it really simple for the students. So this is what it looks like. First we start with drawing a model, and so if students can draw a model of a fraction, they should be able to multiply fractions by a whole number. So if I have something like 4/6 times 3, what that problem is really saying is that I need to draw the model of 4/6. So if I just, there's 6 parts, and I need to shade in 4. So 1, 2, 3, 4. There's 4/6. The problem 4/6 times 3 is that means I need to draw that model 3 times. So 1, 2, 3, 4. So there's 4/6. And if I draw that model one more time, I will have an answer. And so how I show that is I would count all the shaded pieces, and that'll be my numerator, and my denominator always stays the same. So I have 3 groups of 4/6, and that's 4 in the first group, and then I have 8 and 12. So I have 12, 6. So that, the students know, is an improper fraction. When the numerator is greater than the denominator, it means I have an improper fraction. We can leave it like that unless we have a question that might ask between what 2 whole numbers is my answer, or it asks how many hours did the character do an action. So if it asks a question like that, they have to change it to a mixed number or a whole number. In this case, I would find a whole number. I know that 12/6 is really 2 wholes, and the way I can find that is 2 ways. I can do numerator divided by the denominator. The answer, or the quotient to the division problem, would be the whole number, so 2. If I did 12 divided by 6, my quotient 2 would be the whole number, and then my remainder would be the numerator. In this case, there is no remainder, and then the denominator would stay the same. The other way I can do it with the model, and I like that kids are doing this because it's like a foolproof way, they can't get it wrong. What I tell them to do is draw a model with their 6 pieces, and now they need to shade 12 of them. So 1, 2, 3, 4, 5, 6. Oh, I need to draw another. So here it is: 7, 8, 9, 10, 10, 11, 12. So I have 12/6, and oh, I see, I have 2 wholes. That's one way we can do this. If I had another problem, so if I Okay, so if I have a different problem, if I have something like 6/10 times 8, another way we've shown them to do this, another strategy, is to do repeated addition. So what they would do is they would add 6/10 8 different times. I'd do 6/10 plus 6/10 plus 6/10 plus 6/10 plus 6/10 plus 6/10. That's 1, 2, 6. 2 more plus 6/10 plus 6/10, which is going to equal 48/10, which that improper fraction would be an acceptable answer unless we require them to change it to a mixed number. In that case, I can divide or draw models. So if I drew models, it would look like this. Shade it all in. There's 10 pieces. There's 20 pieces. There's 30. Here's 40. And then I have 8 more to draw. So they should have 1, 2, 3, 4, 5, 6, 7, 8. So their answer is 4 wholes, which come from there. And this fraction right here is 8/10, which we're teaching some of them that fraction, 8/10, can be simplified. It's not a 4th grade standard, but they do learn equivalent fractions earlier, so if they know, if they can go 8 divided by 2 and 10 divided by 2, and both of those can be divided out, they can get 4/5. They can understand that 4 and 4/5 is the simplified version. So that's equivalent to 4 and 8/10, which is also equivalent to 4 and 4/5. Okay, so that's one step farther. So that's repeated addition. We've also built a model. We've also taught them how to draw a picture. So they would draw a picture of something like if it was 6/10 of a cup, they would draw, which I realize that there's probably not a measuring cup that's that size. They might draw a measuring cup that's 6/10, and they would have to draw that 8 different times. Well, that to me is the same as doing repeated addition up there. So those are the strategies that the students have learned to multiply fractions by a whole number. I really like when the students draw models, because I feel like there's no way they should be able to get that wrong if they draw it right, and it makes it really simple. It makes them able to see that they should be drawing, in this case, eight groups of 6/10, and then all they have to do is count the shaded pieces. And then they can even make a mixed number by making a different model. So I really like that. I really like the students to draw models. The repeated addition is great too. It shows them that, hey, I need to add this fraction 8 different times. So hopefully they pick up on the fact that, hey, if I multiply my numerator by the whole number, that gets me the same answer. That's kind of the next step, where they go next from this. So that's what we're doing right now with multiplying a fraction by a whole number. Hopefully this helps.